Everyone, welcome back to my channel. If you already watch our video, let's see in XGBoost for the classification, today we are continuous this journey with XGBoost for regression. So I will try to go step by step with numerical example and full explanation, beginner friendly as always. So, before diving into the XGBoost, let's see, regression, let me just quickly remind ourselves what is the regression itself. And in classification, we predict a categorical, like spam or not spam, okay or not okay. It's the class label is categorical. It's limited, let's say countable. And in regression, we are predicting numbers like house pricing, temperatures, salaries. So the class label or the predicted or the target column is a continuous value. It's not categorical like in a classification. So if your target variable is numbers, then you are dealing with regression. So as I already explained or told you in the last video, it's XGBoost is a ensampling and boosting algorithm used to build the decision trees one by one. So and each tree it tries to fix the mistake of the previous one. So let me just say it maybe clearly. So in random forest, it built several trees. In XGBoost or boosting algorithms is trying to build one tree, and in the beginning, let's see, and is try to improve or let's see fix the mistake of this tree of the previous tree. It's not, let's say, building several trees and finally it's just using by footing. No. And it's a great, this XGBoost is great for classification and regression. And today I will focusing on regression. By the way, if you have any data set, try to use XGBoost before using deep learning stuff because it will give you a very accuracy, performance, and also a time. It will take in a second, let's say. And in today's video, I will try also to show you how to use the L1 and L2 regularization. L1, it's let's see, I think it's called uh, ratio. I'm not sure, but L1 and L2. And this L1 is used for the to make the tree sparse. So some leaves will be become zero, and L2 is shrink the value that prevent a huge jumps. So, by the way, L1 and L2 already explained in more detail with real examples in this series. So I can give you about the link in the description. So as I said, now let's just start. And XGBoost, I will try to use gradient descent, also regularization L1 and L2. And let's assume this is our data set here. It has 1, 2, 3, 4, 5, let's see, parameters, plus 1, 2, 3, 4, 5, plus the price. This is our target column. Let's say we would like to predict this price. So if we have a new data here, let's see the median income, and this is house age, this is the average rooms, this is the average occupancy, occupancy. And if we have, let's see, a new sample without, let's see, price, and we would like, our goal is to predict the price. So let's see how the linear the XGBoost for regression is working. It's similar to what we did in the classification, but somehow different steps. Let's see, as always, XGBoost is try to predict constantly the mean of the target values. So if you see here, we have the target values is this one here. They will take the decision, the average of these or mean values of these, and assign it to each row. So let's say, for instance, this is actual price, and this is the initial prediction. The initial prediction is came from the mean, taking the average of this column. And now we will try to calculate the residual. This is called the initial prediction. Now will calculate the residual or error. 300 minus 312, and etc. for all of these. Now we will try to build first tree. The first tree, as I already explained in the classification, it will try, for instance, you have here several columns here, and it will try to all of these columns and plus the threshold or the values in this, and build a tree and try to calculate the information gain and see if this is the good. It will try to split. So as you can see here, for each feature it will try to split all the threshold, then compute the gain, the information gain of each split, and try to split with the highest gain. So if we assume that if the median income is less than or equal 5.5, so it will go to left. If it's greater than 5.5, it will go to right. It's like a tree. Now, if you see here, let's see with the mid income. I will maybe copy this and put it down so we can see it clearly. Oops. So you can see here, this is the median income. It's, as you see here, this is the rule. If it's less than 0.5, so this will be left, and this will be left because it's 4, and this will be to the right branch. Now we will try to sum up all of these. So you can see the residual. We will try to sum all of these. I mean, for the left, we will try to sum all of this up, and for the right also we will sum this up. And you can see here the residual of this and this, it will be minus 45, and the number of samples, it will be 2, and number of samples here also will be 2, and this is the summation of the residual will be plus 45. Now we will try to calculate the leaf values without regression. How do we calculate this? This is the weight. It is G divided by H. The G is the summation of residual in the leaf. So for instance, we have left and right. This will sum of the right and for sum of the left. It's already here. You can see this and this. Now for the number of samples, H will be 2. And you can see this is divided by 2, minus 45 divided by 2. And this is divided by plus divided by 2. And we can see here, this tree, let's see, is predict 22.5 and minus 22.5. So we will now replace this, the initial bit. So we have this initial prediction. Now we will replace this with this new predictions here. But let me add the regularization, L1 and L2. L1 is 5 and L2 is 1. This is assumption. This is as a parameter. You can change it whatever you want. So this is with the regularization. L2, it's G, and just added this lambda here. It's also, and for the L1, it's taking the sign of G, then multiplied by max, the absolute of alpha minus alpha. I think this, taking the maximum of this multiplied alpha, then with the 0. And if you see here, this is minus, and 45 multiplied by 5. Let me just check. Maybe I have done some wrong, maybe calculation. Yeah, sorry, I have done some errors. So we you know what is this? So this is the G, the absolute value of G multiplied by alpha. So it will be 270. But now it will be error. But sorry for this mistake. And now I will try to use to update the prediction. So this, let's see, assume this is the update. So this update will be y hat plus alpha multiplied by weight, which this is the weight we have. We have get this and this. So if you see, this is the new prediction. It will be this multiply plus this and this. This is our new prediction. Let's see. And now we will try to repeat step 2 till till step 6. So for instance, this is our new prediction. We will try to calculate the residual, and this is a step 2, I think. Calculating the residual, yeah. Yeah, and try to build a tree and calculate the values of the with regularization and etc. Now, after several steps, you will get, of course, I mean, because this is a small example, but after several steps you will get the exact, not exactly, or close to the class label, the regulation label, the target column. So XGBoost build many trees, but each one fix the previous one. So it's not building, as I said, several trees. It's only one, but it's just fixing the previous one. And also linear regularization is shrinking the leaf to avoid, let's say, overfitting. So that's why I recommend you to use XGBoost, because uh, it's avoid overfitting, because using the regularization. And they also have this code here. Let me just maximize it. This is the same example I have, as I have done use here, and you can see this is the regressor. It's imported from XGBoost, and you see how I installed this XGBoost in my Beauty. You can have a look in the previous videos. And let's see, yeah, I can just show you. This is the alpha. This is the regression lambda. Alpha and lambda. This is L1 and L2. Let's see. This is the regularization parameters. But I think they have also some default values. So I don't know where is this. But of course they have default values. Yeah, I think this enough for today. And if you find this helpful, please drop like, drop a like and subscribe into my channel, and let me know in the comment if you have any question, or maybe you need a notebook for this. I can do it quickly. Thanks for watching, and see you next time.